Hello, this is the second video, so part 2 on writing a direct proportion equation. Remember, direct proportion is often also called direct variation, so this is the same as writing a direct variation equation. Before we begin, I want to review the equation of direct proportion, otherwise known as FYI, aka means otherwise known as direct variation. So remember, we talked in our last video that y equals kx is our equation of direct variation. Usually this is how we're going to see it. I want to talk about one other way you might see it. Another way of writing y equals kx is to have your equation solved for k instead of y. The equation is currently solved for y because y is isolated, meaning by itself, on one side of the equal sign. So we are going to take this equation and now solve for k, meaning isolate k. Right now you can see k is currently being multiplied by x. We are going to use our inverse operations to isolate k. The inverse of multiplying by x, of course, is to divide by x. So we are going to divide both sides of our equation by x. On the right side, you can tell x over x is an equivalent form of 1. And we get y over x equals k. I can use my symmetric property of equality to rewrite that as k equals y over x. So for this video, we are going to be using this equation quite a bit. So I want to make sure you have this in your notes. These two equations are equations you will often see for equations of direct proportion or direct variation. I want you to make sure they're in your notes. First example, given that the table below represents a directly proportional situation, copy and complete the table and write an equation of direct proportion. Please take a second to pause the video and copy the table. Now, unlike the situation before where we had to determine if we had a directly proportional situation, here we are told this is a directly proportional situation. So now we just need to complete the table. So what we want to do is we want to find what our constant of variation is. Remember, the constant of variation we usually represent as k. In our past video, in the past slide, we said that we can write our equation of direct proportion as k equals y over x, where y is the dependent variable and x is the independent variable. In this case, we can say that the number of rings a tree has is dependent on the tree's age. So for this problem, the age of the tree is going to be our x value, and the number of rings is going to be the y value. So in order for me to find my constant of direct variation, I'm going to put my number of rings over the age of the tree in decades. So for this problem, k will equal 20 over 2, which then simplifies to 10. The constant of direct variation in this case will be 10. Now I need to complete the table. I can write my equation now. I know I'm going to use the equation y equals kx. And in place of the k, now that I know my constant of direct variation, I can use 10. So y equals 10x is my equation of direct proportion or equation of direct variation. Now I just need to complete the table. I'm going to do that by substituting in each of my different x values into the equation to find my y value. So for this first one, I will get, y equals 10 times 3, or y equals 30. So I can go ahead and put a 30 here. For the next one, y equals 10 times 5, or y equals 50. I can put a 50 here. And then the last one, y equals 10 times 7, or y equals 70. I can put the 70 here. So I've now completed my table, and I have my equation of direct proportion, y equals 10x. Here we have another problem. Again, in this problem, the problem tells us that y is varying directly with x, or that this table is representing a directly proportional relationship. And we are asked for the same thing. We're asked to write the equation of direct proportion, and we are asked to complete the table. This time I'm going to complete the table first and then write the equation. It's up to you when you do your problems. So I know I'm looking for equivalent ratios. So I'm going to go ahead and set up my ratio. Now again, you want to set your ratio as y over x. The first one that's given to us is 15 over 6. I would prefer to simplify this. I think it's easier to deal with simplified fractions. So I know 15 is 5 times 3, and 6 is 2 times 3. So 3 over 3 is my equivalent form of 1, and I have 5 halves. I'm looking for a equivalent ratio that is, some number over 8. I know that I would have to multiply 2 times 4 to get to 8. So I would also have to multiply my numerator by 4, and I get 20 over 8. Now I want to find an equivalent ratio that is something over 9, and that's going to be a little bit harder for me. It's harder because 2 is not a factor of 9. So in order to figure this out, I'm going to use cross multiplication, or the cross products. So again, I'm looking for 5 halves as some number over 9. I'm going to just use n to represent that number. Now here I'm going to use my cross products, meaning I'm going to multiply diagonally and set that equal to the opposite diagonal. When doing that, I get that 45 equals 2n, right? 5 times 9 is 45, and 2 times n is 2n. Setting the cross products equal to each other, I can divide both sides by 2. So I get that n equals 45 halves, and I can just use that. 45 halves. And then the last one should be fairly easy, right? Because 5 halves needs to equal something over 10. For my denominator, I would just multiply by 5. So in my numerator, I also want to multiply by 5, and I get 25 tenths. So the number here that I'm missing is 25. Alright, so now I've completed my table. I need to write my equation of direct proportion. The simplified version of my proportion is 5 halves. If I wanted to, I could change that to 2.5 also. That's up to you. So then my equation of direct proportion is going to be y equals 5 halves x. Perfect.